Welcome Year 8s to this video. In it I'm going to take you through some more work with ratios. You did start looking at this in your last lesson. So this lesson what we're going to do is explore more with converting between ratios and fractions. We're also just going to have a look at some more examples of simplifying ratios to make sure that we are well aware of how that's done. And then finally we're going to look at ratios that involve fractions and how we should simplify those, because we shouldn't leave any fractions in a ratio. We want to aim to work with having whole numbers in our ratios only. So that's our intention, and that's what I'd like to, by the end of this video, have you feel confident with. If I have a look at the first example for you, what we're going to be looking at is obviously ratios and fractions as our first learning intention, but I want to do that through looking at a couple of examples. So with this first one, we have an alloy. So that just means that's a metal that's got, I guess, multiple metals mixed together. So we've got this alloy of gold and silver. So it's a mixture of gold and silver. And it contains 2 parts gold and 5 parts silver. And it says there that that's by mass. So if we had, say, 200 grams of gold, that means we would have to have 500 grams of silver if each part, of course, was, say, 100 grams. That's just an example, though, to help you understand what we mean by mass. In terms of the first question, what fraction of the alloy is gold, we first have to consider how many parts are there all together in this alloy. If we have 2 parts that are gold and 5 parts that are silver, and we add them together, we can see then that we have 7 parts all together. So I'll put out of 7. In terms of what fraction is gold, only 2 of those parts are gold. So, whoops. It's not letting me put a 2. 2 out of 7, or 2/7 of this alloy is made up of gold. Of course, silver will have the same denominator, but this time we have 5 parts must be silver, so 5/7. Now, if we consider the next question, how much of each does 700 grams of the alloy contain? First of all, we know that in the alloy there's 7 parts altogether. So we can add up our 2 parts gold and 5 parts alloy. So what we can do is we can take our total, our 700 grams, and we can divide that by 7 so that we can see how much each part is. So once we do that, as you can see, 700 divided by 7 will give us 100. So each part is 100 grams. So we do need to know how much each part is, because we know that 2 parts have to be gold. So 2 of the parts, so 2 by 100, will give us 200 grams must be gold. And that means that 5 parts, so 5 by 100, is silver, so we have 500 grams. Of course, when you add them together, you should get our 700 grams to begin with. And if we were to simplify 200 to 500, that would, of course, simplify to 2 to 5, which is what our original ratio was telling us. It was a 2 to 5 ratio. So there we have one example of where we've converted the information that was given as a ratio into a fraction, but then we've of course used that ratio to then try and find the answer to this second question. We had the total amount, so how much must each have contained. Just looking at a second one now, this one here gives us a fraction to begin with, and then it asks us to convert that to a ratio. So we're told 1/10 of the population likes Brussels sprouts. So then what is the ratio of people who like Brussels sprouts to the rest of that population? So if we consider then 1/10, they like the Brussels sprouts. So I'm one of those. I love Brussels sprouts. So how many, or what fraction do not like? Well, if 1/10 like, then we must have 9 out of 10 who don't like Brussels sprouts. And so therefore we have a ratio that looks like this, 1/10 to 9/10. Now we don't want to leave it like that. We want our ratio to have whole numbers. So if you want to make a note, ratios should have whole numbers, should contain whole numbers. Now, luckily for us, any fraction that you have, like we have here, that have the same denominator on both sides. Just finish writing this before I get to that. It's actually really straightforward to transfer this to a simplified ratio, because if we have a look at this is saying 1/10 and 9/10, and so really the parts in each case are tenths. And so if you've got one of them and you've got 9 of them, the ratio of course is just 1 to 9. Another way of looking at it is you can just times both sides by 10. That will then simplify to 1 to 9. Simplify our ratio to this here. So often I don't even bother with doing the times 10 times 10 because I can see I've got the same denominator on both sides, which means that my numerators form the ratio. Just one more worded question here before we get to just some simplifying. We've got a batch of concrete made from sand, water, cement, and gravel. Okay, so 10 kilos, 5 kilos, 2 kilos, and 2 kilos of gravel. So before I start, just because I didn't have a lot of room, so if we do, this is first, this is second, this is third, and this is fourth. Just so that our order is correct, because of course when we write a ratio, the order is very important. So first I'm going to put the number of parts of sand that are required for the concrete. Now if I do a quick check first, I'll see that each of these weights that I've been given, they're all in the same unit. Now that's very important. If I had some values here say that we're in grams, then I would need to make sure I'd convert all of them to the same unit first before I write my ratio. They are all in kilograms, so start off with my sand. Second one is 5 kilograms of water, so 5 parts water. 2 kilos of cement, so that's 2 parts. Of course, each part here is a kilo. And then the last one is 2 kilograms of gravel. So I've got 10, 5, 2, 2 is the ratio of those ingredients that make up the concrete. Finally, express each ingredient as a fraction of the whole. So just like before, I need to know how many different parts there are. So I've got 10, 5, 2, and 2. So 10 and 5, 15, plus another 4. So I've got 19 parts altogether, which means that my denominator of the fraction has to be 19. So since there are 4 ingredients, I'm just going to put 4 fractions. And if I do it in the same order, first was sand. So if you have a look here, I had 10 parts was sand. I might just label it above. Second was the water. We can see that there are 5 parts water, so 5 on 19. Then I've got my cement. And finally, the gravel. So just make sure when you are creating a fraction that you do look at your total parts first of all, because you do need to know what your denominator is going to be. There we go. Okay. What we might do then is have a look at the last thing I wanted to cover, which was simplifying ratios. Now, with simplifying ratios, you did do this in our last lesson. You watched a different video for me. So a nice straightforward one to start off with. If you have a look here, we have got, that colour's not very good, I'm on a yellow one. If you have a look here, we've got 15 to 80, and we want to simplify it so that we've got two numbers that share no more common factors apart from 1. So you want to consider what your highest common factor would be. When you are simplifying just with whole numbers like this. It's a bit different when we get to fractions, so we'll do that in a moment. I've got, I think, 3 examples here that involve fractions. They will work a little differently. So this first one, we're looking at 15 and 80. So first of all, I consider factors of 15, and I've obviously got 5, and I know 5 and 3, of course. And I know that 5 goes into 80. So what I'll do then is divide both sides by 5. Like so. So 15 divided by 5 will give me 3. And then I need to do 80 divided by 5. So there's a few different ways that you can do that one. I like just going to 20. So there's 25s in 100, and 80 is 20 less, so that would be 4 5s less. So 16 5s will give us 80. You obviously, if you haven't chosen the highest common factor, it means that you'd still have a common factor between these two numbers, but I know that 3 doesn't go into 16. So I know now that that is simplified. That's my final answer for that one. Sometimes you can have 3 numbers in your ratio or more. So when you are simplifying with these, you want to look for a common factor, obviously the highest as well, but the highest common factor that goes into all 3. So look at your smaller ones, because your smaller ones don't have as many factors. Of course, 2 is prime, so its only factors are 2 and 1. So what you want to do is consider, does 2 go into 6 and does it go into 10? Yes, it does. So I'll divide the whole lot by 2. That doesn't look like a 2, so I'll fix that. So 10 divided by 2, 2 divided by 2, and 6 divided by 2. So I have 3, 1, and 5. So now the only common factor there between those numbers is 1. And we're not obviously going to divide or bother dividing by 1. Just onto something with fractions now. We did simplify something with fractions before and it had the same denominator, but now we're looking at one that has different denominator. So what we want to do is make sure it does have the same denominator, because then our simplifying is really straightforward. I showed you before how when you have the same denominator, your ratio would just be what the numerators are. So the only odd one out here is the 5th. I want that to have a 10 as the denominator, so I will multiply the bottom by 2, and what I do to the bottom, I'll do to the top. So I'll be left with a 10th as my first number. I'll have 2 tenths as my second, and then I will have 7 tenths as my last. Of course, that means now I've got all these 10s here, so I'll times the whole lot by 10, each of them, and that will cancel them out. So I'm looking at 1 to 2 to 7. In other words, a tenth is the size of the part, so 1 tenth to 2 tenths to 7 tenths will simplify to 1 to 2 to 7. Sometimes you've got something like this, so a mixed number. I've got 4.5. And now I don't want to have any fractions in my ratio. So I'll show you a couple of ways that you can look at this one. First of all, the easiest thing I think is when you've got a half here, if I multiply that whole number by 2 and this whole number by 2, that'll eliminate this half here. So I'll show you first that method. So I'll have 6. And 4.5 times 2, well, 2 fours are 8, and 2 halves gives me 1, so that will be 9. Now, if you have a look here, now that I've done that, I've actually got a common factor here that's possible between the 9 and the 6. because I can divide both of them by 3. 3 was the common factor. So that will give me a simplified fraction 3 to 2. Now, alternatively, with my 4.5 and my 3, I could have done this. I could have changed that 4.5 to an improper fraction. So that would give me 9 on 2. So 4 times 2 is 8 plus the 1 is 9. That's where I got the 9 from. 9 over 2 to 3. And then I could times both of those by 2. Now that would give me the same thing that I've got up here. I'll times it by 2. I'll get 9 to 6, and then I'll finally simplify it. So if you do prefer working with improper fractions, by all means you can do that. The last one that we're going to look at has 3 fractions in it that are all different denominators. So this one only had one that was different, but you will see here I've got 1/2, 2/3, and I've got 5/6. So what I'll do here is make sure, well, first of all, I'll look at these and I'll see, is there a number that I can by creating equivalent fractions, get all of them to be the same. So I'll look at my highest one here, which is 6, and can I multiply 2 to get 6? I can times that by 3. I'll do the same to the top. And can I multiply something by 3 to get 6? Yes, I can. Times that by 2, and I'll times that by 2. So really what you're doing is you're looking for that lowest common multiple of the 3 denominators that you're working with. So sometimes you may not have a denominator here that you can just convert the other 2 to become. You might have to consider converting all 3 to a multiple that's common to all 3. So on the top I'll have 3/6, because of course that's the same as 1/2. I'll have 4/6, because that's the same as 2/3. And then I've got my 5/6. Now, beautiful. Now that I have all of the same denominator, you can see that my ratio is just going to be 3, 4, and 5. In other words, I have multiplied all 3 of these ratios, of these fractions, I should say, by 6, which has eliminated this from the denominator. But like I said before, once you recognize you have the same denominator, the numerators will form your ratio. Okay, I'll stop there because we need to do some practice with these, particularly with the fraction ones. I know that some of you get a little bit afraid as soon as a fraction appears in a problem, but as you can see, it uses the same skills that we already have covered before with fractions that we've practiced previously. That is creating equivalent fractions, or say converting to improper fractions before multiplying to create a whole number.